Everyone. First of all, thank you for taking time out of your day. Today, I'll really go over kind of proactive API security. First of all, what is API security, why you need to pay attention to it, and then the best approach to really attack API security. Here at Checkmarks, we like to say shift left and integrate right. What that means is really paying attention to security from the design phase all the way to production of those APIs. First, a little bit about myself. I'm Bryant Schuck. I'm a senior technical product manager here at Checkmarks. I come from a software engineering background. I've been doing it since a little kid. You could call me the friends and family IT guy growing up. In college, I studied computer engineering with a minor in security. I really fell in love with hacking. I always thought it was awesome to hack my friends' printers and, do small ethical hacking things, never really full time. I've done everything from converting COBOL to Java to being a full stack JavaScript ninja. I actually had my own startup in 2017 when I fell in love with my product career. I really saw that there's a whole life cycle of software. It's not only the lines of code that matters, but there's ideation, talking to customers, then actually writing the code all the way out to go-to-market strategies. So my IDE nowadays is usually PowerPoint. I live in PowerPoint. I feel like I create hundreds of PowerPoints a week. I'm also a master of Excel. I love data. I love getting into the analytics of my users and how they're using our products. I still have to tap on my wife's shoulder to help me with Excel. Fun fact about myself, I used to write vulnerable APIs. So if you're watching this presentation today and thinking, that API or that microservice I just broke up, maybe I didn't do that correct. It's okay, right? What I want from this presentation is everyone to be able to go back and take action, right? Be able to have the information, knowledge is power, just knowing about API security and what attacks are happening, that's going to help you create safer and more secure APIs. So, everyone always asks me as a software engineer in the IT field, hey, Bryant, how do you explain this to your mom, your wife, your family members? Obviously, hopefully everyone knows what an API is, an application programming interface. Really, it's just going to be a way for two items to talk, right? That might be microservice to microservice. That could be client to server. The Wikipedia definition's up there. But when I take a step back and try to see how do I explain it to someone who has no idea what a server, client, or microservice is, and those words are foreign to them, I really try to take it as like a restaurant, right? Everyone can walk into a restaurant and everyone can order food. Why is this? That's because between the human and the restaurant, there's a contract. We call this a menu, right? You can go into any restaurant, open up the menu, see what they have available, and communicate with the waitress or the chef and get your food back. Pretty simple example. So, I kind of drew out this outline of, how this actually works. The menu says that there's an item, burger, it has some toppings, and it comes with a drink, right? So then as the client or the customer, I walk in and I say, okay, I want to get a burger. I want that burger to have cheese on it. And I also want a drink. Perfect. The chef can give me that food. I'm happy. Everyone's happy. I'm full. This is exactly what an API is, right? I knew from the menu or the contract that I could actually get a burger, and this is what would come on it. Pretty simple, right? So how does security fit in? What are these attacks, right? If we take this example, a very simple attack would be, what happens if I ask for a refund? What happens if I tell my waitress and I say, hey, this burger was undercooked, the drink was flat, I want a refund, and I want a refund of $100. What would happen? I don't know, right? I don't know. It depends on the human. It depends on that day. It probably depends on the restaurant if they give me a refund. Now, how did I know to even ask for a refund? It's not documented. It's not actually on the menu that I can ask for a refund. But over time, over different restaurants, in the society, we know that there's kind of this unwritten rule that you can ask for more than what is actually in the menu. And this is exactly how API attacks are happening today. They're not sophisticated. It's not someone blasting through 7 servers and 5 firewalls and, the old school black screen with numbers everywhere trying to hack in. Really, honestly, in today's world, everyone can hit APIs and everyone can try things with these APIs. There's really no limit on what you can try. If you have a public API out there, I can hit it right now and I can put in any information I want. And I may see that that worked. I may see that it didn't work, but it gave me more context, right? It gave me what data is dealing with. So in this example, I knew that I could ask for a refund. I asked for a refund, and now it's up to the waitress or the server to tell me, does that go through? The other point to this is, what do you think is going to happen if I do get a refund? Do you think that I'm going to go back and order $10,000 worth of food and then ask for a refund? No, I know that they're going to deny me. I know that the waitress is going to say, Bryant, there's no way that I can give you a $10,000 refund. Why'd you order all that food? But what I can do is maybe once a month go back to this restaurant and ask for a refund, right? Maybe if I spread it out far enough, they won't notice that I'm actually taking advantage of their restaurant. And this is the second part of API attacks. Attackers and bad actors are not going after APIs and stealing all the data at once, trying to just DOS the server and take all the data that they want. They're really trying to act like normal behaviors and normal users, right? They're trying to just slowly take this data away so no one notices, right? They've basically found a vulnerability or they found a way to get valuable data, and they want to take as much as they can without anyone noticing. So the second part of this is API attacks are usually long-lived, and they're usually a slow drip of information. So why API security, right? Why is APIs becoming the next attack vector, right? Well, the first question I always ask my customers or clients or anyone I talk to about this is, how many APIs do you have, right? How many APIs do you actually have, and how many do you know that you have, right? It's a tough question to answer because a lot of times it's microservice to microservice. Maybe you have documentation, maybe you don't have documentation. It's a really tough question to answer. The other thing in the industry, we're seeing an explosion of APIs. Someone's actually saying that it's estimated to reach 1 billion APIs by, like 2030, right? 1 billion APIs. I had to actually take a step back and think about that number, 1 billion. That's almost 31 years of 1 billion seconds. And then I was like, okay, well, there's got to be a lot of applications out there, right? There's only 2.87 million apps available on the Google Play Store. And the difference between 1 million and 1 billion is a lot, right? 1 million seconds is only 11.5 days. So 1 billion, 31 years, 1 million, 11 days. That's a huge attack surface. And then we have to take a step back and think, okay, are all of those APIs secure? Are all of them actually baked in with security, behind WAFs, configured correctly, not dealing with sensitive data? Good luck. And even at the scale of your own company or the APIs you write, it's still a tough job to do. So, really that explosion of growth is due to some key factors. We're seeing business and technical benefits. I'm sure a lot of these are buzzwords, but it's probably happening in your company today. You're probably asked by your managers or your leadership team to say, hey, can we move from monolithic to microservice architecture? And your response is, of course. We all know that building smaller pieces is better. We all know that separating dependencies is better. So microservices sound great. Well, how do those microservices communicate? APIs. It's an industry standard, right? And an API first mindset is coming, right? Everyone's saying, hey, if you have APIs, we know how to communicate, we know the standards, we know how data's passed, REST, gRPC, any of those standards, they're great to follow. Also, hey, if we start designing these APIs first, that's going to make development and the outcomes better. So it sounds great. Technical and business, again, they're aligned. It sounds awesome. Competitive advantage. A lot of businesses had to do a hard pivot for COVID. They took their APIs they've been developing for years, and maybe those were web APIs, shifted those to a mobile API, and boom, now you got a mobile app, right? It's a competitive advantage for business to just kind of take these APIs, lift and shift, reuse, whatever it may be, to try to keep up with the market and the ever-changing trends. And then, of course, integrate with anyone and anything. When you think about cloud transformations, when you're moving from your on-prem databases to cloud databases, how do those communicate? APIs, right? So all of these factors are really weighing in, and that's why we're seeing this explosion of growth and exponential, going to reach 1 billion APIs in the next 5-10 years. That is allowing this kind of attack surface to really, really get bigger. And because of all these things, business and technical, everyone wants to move really fast. This causes some key challenges. So let's look at the left here. So the majority of API attacks, every company has probably had some sort of API attack. I think it's in the 90 percentile of companies have had an API attack. And we're not talking about the insurance companies or the banks. We're talking about really bleeding edge software companies, right? Facebook, Coinbase, GitLab, T-Mobile, all of these companies that pride themselves in software and kind of this really leading the community, they have these challenges, right? And these challenges really fit around, is security baked in? Right? Security isn't something that's usually taught in college or these boot camps. Really development has become kind of the skill that writing code is important, writing the outcomes for the business is important, but many developers aren't taking a step back to actually train themselves around security, right? Actually writing these APIs with a security mindset and making sure that they're protecting against attacks. We do have a tool, code bashing, learn about security, train yourself on security. It's one of the biggest differentiators in the market. The second one is shared responsibility. APIs go through full life cycle like an application. The business writes some requirements, they give it to the development team gives it to the testers give it to networking. Does anyone really know that that API that you developed that you thought was going to be private behind a firewall actually is private and behind a firewall? Usually developers lose sight about this, right? Usually a developer that writes the API has no idea how it's actually deployed. And it might be just a miscommunication. Every time there's a handoff, there's an instance where someone may or may not actually complete that handoff successfully. And then ever changing, right? In business and in technology, something that you wrote a year ago may have a whole different life cycle now. We see this a lot with our customers. The developer that wrote the API 2 years ago wrote it for just a couple users to use. Now all of a sudden someone new came in and said, hey, this API is awesome. We should give it to a customer. Customer X says, hey, that was a really awesome API. The business says, hey, if they liked it, let's give it to this customer. Soon enough, that API that was originally written for this very specific use case is no longer used in that fashion. And that leaves it really, really vulnerable, right? And then you take all these challenges and you multiply by the number of APIs that you have, right? This is like taking a menu with 4 or 5 items. That's pretty easy to check over, blasting it out to thousands, right? Do you understand your full attack surface? Are you thinking about security as you write new APIs, as you change APIs? This is what we really mean by shift left. We need developers to really be at the core of API security. So what is API security? What do you want to go read about? I really recommend everyone after this goes and reads the OWASP API Top 10. We were big contributors to this. Our security team does a lot of research. We've really tried to help the market learn about security attacks. Like I said, code bashing is one of our great products, but also being able to actually give back in a free way, right? All this information is free. All you have to do is go and take some time to learn about it. Ask your managers. If you're a manager, make this mandatory for your teams. You know, there's 10 of these. And like I said at the beginning, these aren't sophisticated attacks, right? These are things that you can code against and think about as you're making APIs. The one I want to point out is number 3, excess data exposure. It's the one that I used to fall into a trap, right? As a backend developer in Node, I was like, everything's a, you know, everything is obviously a data structure. I can just pass this object to the front end. I'll let them deal with the data, right? So back to our approach about the hamburger, you know, I know that there's a refund there, but I won't, you know, I'll let the UI know that not to show the refund attribute, right? I'll just pass back whatever's in the database. Excess data is huge, right? If the UI doesn't need it, if the client doesn't need it, don't pass it back, right? We have to, on the back end, know those requirements, know exactly what the data needs, because maybe someone doesn't come in from the UI. Maybe someone doesn't read your documentation. Maybe someone just hits the API and looks at your, you know, data configuration and keeps trying until they get something successful. That is what we're afraid of. Those are things that you can protect against today. So how else can you secure your APIs, right? You know, like I said at the beginning, we really take the shift left and integrate right approach. We really want to make sure that it's that full life cycle security. It's not only just one spot in the life cycle. I really see developers being key, and then making sure that, you know, those handoffs are secure. Another great thing that we offer here at Checkmarx is the ability to go scan your Swagger and open API documentation. So if you're sitting here and I'm kind of making you think, you know, we need to take action today, please do. This is free at kicks.checkmarx.net. All you have to do is upload your Swagger JSON, and we'll spit back all the risks that we find with that Swagger document, right? This is a great free resource to kind of get initiative in your companies. Like I said, if you're a developer and you want to really take that initiative, stand out, this is a great way to do it, right? It's really easy to bring back this report to your boss or your manager and say, hey, I think we need some time in the next sprint to go fix this stuff. Rate limiting, access control, just structure and semantics overall. Any of these things, if a user or a customer finds these first, you're in trouble, right? So go protect yourself, go scan now, you know, go take advantage of these resources. When I talk about the API lifecycle, what we see today's world, design first, right? Like I mentioned, API first mindset. Go build that menu. Go see what you want to offer to your customers. Go see what the microservices need. Build that contract between the technical team. Build that contract between the business, right? I can already vision back in the day when I was a software engineer, we used to do this on the whiteboard. You write down the object. I know with virtual, it's probably harder, but it really makes sense to design and think about these things. If you have security baked into the design, your API is already better, right? It's already going to be more secure. Once you start developing it, start thinking about those SaaS vulnerabilities, right? Start thinking about what your SaaS tools are telling you, right? If you use Checkmarx SaaS, start looking at those vulnerabilities. Does this API use those vulnerabilities? It's really what our product's out to do with API security is look at this holistic approach, start tying these objects together, start aggregating this data together. Testing. A lot of testers are testing just to make sure that the feature works or that there's no broken pieces. Who's testing for security, right? We want to make sure that you actually attack these APIs like someone would, right? So it's not only about the outcome met for the business. It's not making sure that your code works. It's making sure that the full life cycle works. And then production, right? No matter how much you do in design, development, and testing, someone can always make a mistake, and that API that you thought was private goes public, and then, maybe it wasn't as clean as you thought, and you're in trouble at that point, right? So, we want to give you the full context. We also want to make sure that each step of these, every developer, every engineer, any networking team realizes that APIs are going out the door. And the reason why I think this is most important is because it's not one application, right? One application, pretty easy to secure throughout the whole life cycle. Put it behind a firewall, it's just one. Again, how many APIs do you develop? How many are released every day? How many are changed every day? Each one of those is going through this life cycle. So what is our approach? Our approach is that shift left and integrate right? What we want to do is start with static analysis, scanning your source code, scanning your API documentation, giving you any vulnerabilities as early as possible, any risk as early as possible. Obviously, moving into the testing phase, this is where we see a lot of that business logic. Once you do deploy it to a server, actually hitting that logic, being able to test that logic, being able to see, hey, is this user A with this authentication going to be able to get to this resource, even though user B can? When you think about this type of stuff, it's funny because with the T-Mobile attack, all that happened was that someone put a phone number in the URL. Someone noticed that it was a phone number, right? 10 digits, whatever it may be in the URL. They changed it and they were able to get other people's data, right? So we're not looking at sophisticated attacks to test against. We're really looking at, in static analysis, did you know that there was sensitive data in there? And testing, did someone test against it to see if they could fuzz those numbers and get more data back? And then runtime, how's it actually being released? Was it a web page that showed the full URL with that phone number in it, right? With this approach of all the way from left to right, we really see the holistic approach to API security as being the winning solution. So what are the core pillars? That's nothing new, right? Application security, it's the same thing. We want to make sure we're protecting ourselves from the left to the right, but APIs are a little bit different. The first thing you really have to do is do discovery, right? You want to make sure that you discover your complete API inventory, right? What is your attack surface? From there, you can start making educated decisions, right? Knowing how your APIs are called, not only from outside in, but also microservice to microservice, right? We call this north to south or east to west, right? Knowing how all this fits together and how all these APIs are used is key for security. The second one is risk. Obviously, knowing your risk, knowing which vulnerabilities are found in static analysis, knowing where there's misconfiguration, all these things are going to help. Prioritization, allowing our users to actually go and figure out the OWASP API top 10, stale and zombie APIs, bad practices. And what I mean by this is we know there's a lot of APIs in your code, right? Which one of those are actively used? Which ones are actively being used by your customers? Which ones maybe should you delete? The scariest thing when I talk to customers about this is they find an API that's been in their code for 5 years. No one on the team knows what it is, but everyone's too scared to delete it. And then we come to find out that's actually a public API, right? Hasn't been updated in a couple years, still using old security practices. This is very vulnerable. It's hard to find, but not impossible. And then remediate. One of the core things at Checkmarks that we're trying to get across is developer-focused remediation. We want to make sure that when someone finds a security incident, they can easily get it back to the team and be able to remediate it as quick as possible. Being able to see the lines of code, being able to do curl commands, whatever it may be. So how do we mash this up? How do we take the strategy and the core pillars and kind of make this holistic approach? We really see that static, dynamic, and runtime analysis is key. Each of these is going to meet the pillars. So when you do static analysis, you're going to get that complete attack surface. You're going to see every API that we can find in code. We see this as key to the story because obviously you got to know what your attack surface is. Data discrepancies. What's the difference between documentation and your code, right? Go all the way back to the beginning when I was talking about the refund. That wasn't documented, but as a human, I knew that I could hit it. Those are data discrepancies that we want to find and, really squash. I know I've worked on some teams where I've heard in the background teams saying, hey, you know what? We'll just document these 3 attributes. That way the user won't know there's 3 others. This day and age, someone will find that, someone will attack it. And then the third thing is sensitive data. We know APIs pass around data. Some data, it's okay. Some data, it's just generic data. It's UUIDs, it's whatever it may be. But at some point, your APIs are going to deal with sensitive data. Which ones are those? Which ones should you pay attention to? Why is that important? And like I said, remediate, being able to go down the line of code and specifically being able to tie these back to SaaS results, being able to know that this code injection is also used by an API really helps the full picture come together. And then when you layer on testing and now you take it to the next level and this API gets deployed out to a server, you now know the full path to the API. You can actually start attacking the API, finding business logic and OWASP API top 10 vulnerabilities. Remediating these are really easy, right? Because they're curl commands, because you can actually hit these, from your terminal on your computer. I find this the most fun, right? Once I find a vulnerability, it's actually trying to reproduce it, trying to fix it, trying to figure it out. All these are steps that you can take as a developer. And then the runtime analysis, being able to see how these are deployed in your WAF, being able to see what API gateways they're behind, making sure that when you develop this and the business told you, hey, don't worry, this is not going to be public. We're only going to give this to one customer. It's going to be behind the WAF. No worries, right? Protect yourself, right? As a developer, making sure that you follow the full life cycle, making sure that you have visibility into this. That's really important, right? Making sure that you actually know how this is actually deployed and the outcome has been met. So with our tool being able to go through kind of the runtime analysis and giving you that full context, between these 3 strategies and the core pillars, we really see this as a holistic approach and, the best way to make your API secure. So thank you. I hope this was informative. Really, if anything, I hope it alerts you that you should really go look at how many APIs you have and take accountability for that. The best thing I can advise any developer, any engineer, any manager is to start today, right? Even if it's reading the OWASP API top 10 and doing some training on that so you can make sure your APIs are secure, please go do that. The next thing is go scan your Open API or Swagger documentation. That's a great free tool at kicks.checkmarks.com. Anything that we can do to help you keep your API secure, that's what we're here to do. Obviously, we got products that can really help you secure all of your application, not only APIs, but your full application lifecycle and your infrastructure as code. If you want to get in touch, my name is Bryant Schuck. I am located in the States. You can always ping me at bryantschuck@checkmarks.com to learn more about our solution. Or if you just want some guidance from our security teams, we're happy to have a conversation. And then in Poland, we also have a resource there. Please get in contact with him. And I look forward to talking more about API security. And if you haven't seen, we have a code bashing championship up next. So if you got nothing to do after this talk, if you're not going to go scan your Swagger documents immediately, definitely go join that, right? Go learn something, because again, the biggest thing is knowledge is power. Once every developer knows about these security practices and what is a vulnerability, you can start protecting yourself. So with that, I'll wrap it up and back to the studio.